Finally getting back to the video on the Denon M44 build. Time to start reassembling now. And I'm just going to measure this shaft on here for reference when I do whatever I end up doing with these idler tire wheels. If I make some more, I just want to have a reference written down, know what the diameter is that I'm dealing with, not just the diameter of the bore that I measured before. I'm just going to lightly scuff up the felt ring. Doesn't take very much at all. I'll scuff it up and clean it. These are replaceable if I ever need to. Well, come on. I only want to put the lube on the bore. I don't want to put any on the shaft because it will force it down and possibly contaminate that felt. Put it back together and clean it up. Start to assemble everything, lubricate every contact point and every pivot point. This is the DuPont EM30L. I'm almost sure is the number on that. Lubrication, the grease, isn't just for friction reduction. It's also used for dampening. Everything that's in this mechanism can work its way into the tape. Even though it's plastic, plastic still resonates. It just doesn't transfer sonic waves at the same speed that metal does. You probably know this, but sound waves travel through metal considerably faster than they do through air. And so micro vibrations and resonances can get everywhere. And it just takes a very little bit of effort to try to dampen those things in the process of, putting this thing back together. Every little bit helps. It really does. Yeah, I'm going to take these heads off and have a good close look at them. I had a little bit of attenuation, recording attenuation. The playback side was fine. One of the record channels was a little bit off, and I want to see if I can take care of that. So I've got under the microscope here. This is the record head. I'm really not seeing anything so far that would lead me to believe I should have any problems with this head. But right there, what's that right there? Okay, so that's a little bit of something. You know, it doesn't look like breakdown really. It looks like maybe what I saw in the other heads, just oxidation from non-use. Looks fine here. Let's get in a little closer. Yep, just right there. Yeah, that to me does not look like breakdown or chipping. That looks like something on the surface. And I think that possibly could accommodate for that slight attenuation in the recording. Sorry about the lighting here. My lamp house actually burned out right before I did this, and so I'm holding a flashlight on this manually. I've got it repaired now. I can, or I've got a new lamp in it now. I can get back to normal. Flashlights don't, they don't work out so well. But it got me what I needed to see. That, that looks fine. And, you know, I'm looking for any sort of grooves or divots. Uh, and you know, there's just not that much wear on this head. 5%, maybe 10 at the absolute outside. This head has plenty of life in it. Yeah, I'm very happy with this. Just right there. Let's see if we can deal with that. So this is going to be one of those don't do this at home kids moments. I'm going to polish these heads out very aggressively. And you know, I don't recommend this for anybody. I have a long background of abrasives and materials and a lot of experience doing this kind of thing. There probably isn't a day that goes by that I'm not grinding or honing or lapping or polishing something. And so I have a pretty good feel for it. The hand polishing here is fine. I think anybody could do that fine, but I'm going to get a little bit more aggressive with it here in a minute. Now that I know what I'm looking for on that head, um, I can see when I've got it polished out. And doing it by hand there did not, it got part of it out, but it didn't get it all out. So like I say, don't do this. I'm sure if I would have done this for the first time, I would have ruined whatever I was working on. But after 40 plus years of doing it, a guy just kind of gets a feel for it and knows when to stop, knows when to change abrasives, how much pressure to put on. There's a point on these things, you'll see me change out the swab often. There's a point that you start picking up enough material that material starts doing the polishing, but it's not doing polishing anymore, it's doing scratching. So it's necessary to change that up often, and it's also something where the compound breaks down as it's in use. So every time you put new compound on it, you're actually going down a grit, not up. And you just have to have a feel and know when to, when to do what to do. So don't do this. This isn't a tutorial. This is what I'm doing. Well, do it at your own peril, I guess, is the best way to put it. So at this point, it's actually cleaned up, and I'm just going through and kind of doing a little bit more polishing. I'm polishing those guides out and just doing a final polish on it. If you watch the video before this one, where I actually test the deck, it's apparent that this worked out just fine and took care of my slightly attenuated record channel. Now that had about the tiniest amount of compound on it that I could put on it. I'm mostly dry polishing it at this point. There's pretty much what I used up. Okay, now while this is freshly polished, thanks to a viewer comment who made me aware of this product that I knew about years ago but forgot the name of. I am using it now. It's a, it's a non-stick, it's a dry film lubricant, of course, but more than that, it actually protects from oxidation. A lot of us have a lot of decks and we can't play a tape on them, as often as they need to keep the surface from flashing. And so something like this will protect that and stop any oxidation that takes place. It has the benefit of making the tape slide more smoothly also, but I'm actually applying this to most of my heads that I don't use frequently anymore. Even the new heads in a video a few ago shows how they oxidize without even being used. Just sitting in a container, they oxidize. So this will slow that down or prevent it, easily prevent it until it gets back to its owner. Just clean up this mount a little bit. I think this is going to be my longest video that I've ever made so far. So buckle down, get some popcorn. I hope it's not too boring. There's a lot going on here, and I'm fast forwarding through most of it. I think I've consolidated somewhere close to 5 hours of video down into an hour and a quarter. And it's been some work, but it's been fun. Okay, so those are the bearing races. I want to get all the way to the bottom of this and clean everything out and apply new lubricants throughout. And this isn't bad. This is not a very dirty one at all. When they have these overmolded components, I really don't like to put these in the ultrasonic. It might be fine, but I can clean these up like this just fine. You know, I even avoid Q-tips doing this kind of work because of the fibers that come off. I just use these electronic swabs, and these pointed ones, I think they're cosmetic swabs, but they have a really good use. And then looking at the brakes too, I can tell that it hasn't had a lot of use. Okay, this is the PDP 65 capstan lube, capstan bearing lube. This is damping grease for those ball bearings. for the head assembly, or the head bracket assembly. I wouldn't just use any old grease on this. This is a damping grease, and this is I think it's a medium damping grease I use here, and a heavy damping grease on the top one. These don't really need grease for sliding. They need grease for damping. It's, you know, it's a lot like watchmakers. A watchmaker wouldn't buy one oil or one grease and use it everywhere in a watch. It just doesn't work that way. They take different types and styles of lubricants for different purposes. And although I don't have any kind of a lubrication schedule on this deck, you know, from Denon, I'm kind of familiar with what has to go where. I deal with this kind of thing every day. Now, there's the brake pad. Looks good, a little dirty. And what I'll do with this is I'll just put a little alcohol on the towel and just kind of dab it in there and blow it off. It doesn't need anything more than that. Give it a little scuff. I'm just using a brass cleaning brush on that. The particular type of grease here only really needs to be compatible with plastics. And so I use the DuPont stuff. I don't use silicone greases in my shop at all for anything. But I do like this synthetic EM30, I think it's called. Try to get a little bit more in frame here. That's the Nye medium damping grease, and I'm just adding a little bit to the back where it makes contact again. I can see where it goes because I can see where the bearings have been riding. That feels really good. Just smooth as butter. Okay, this is the hold down, and I'll use the heavy damping grease on this. And really all that does is hold those other 3 ball bearings in place for the travel of that assembly. And that's mass coupling the assembly to the transport. So it's putting, a relatively small amount of pressure, but it's putting pressure on an extremely tiny spot on that ball bearing, on those 3 ball bearings, or 4 actually. So even though it's not a lot of force, because it's concentrated on such a tiny spot, it's a huge amount of pounds per square inch, PSI. When the reels are installed, there's 2 little pins that engage those copper plates, and they just need to be kind of rotated a little bit until they find their slots. Those are so tiny, I just kind of store them on a little wire so they don't end up someplace where I don't want them. Okay, so I get the lubricant on there, and then I just clean it off with some alcohol. IPA, I should say, not rubbing alcohol. These are the original plastic stoppers or clips. And if I have, and I should have some E-clips to replace those with, I'm going to go with that. I believe these are 3mm, and I should have 3mm E-clips. That's the one. Perfect. All right. That'll be a lot nicer than those plastic ones. These are for the pinch roller shafts. Now, I've already lubricated them. These are sintered bronze bearings on a brass hub. These are the factory rollers that I've precision ground. And that's my lube spot right there where that little bit of wear is. The other thing this lubricant does, it just kind of quiets the operation down a little bit. And in the end, this transport does operate very quietly. It's a pleasure to use. What I was about to say was I do lubricate that sintered bronze hub on these, and that's should be lubricant, for life until they're ever used again. If I run into brass, which I don't run into brass very often, but brass is not self-lubricating, and so that needs just a little tiny bit of oil on a regular basis. Yeah, I like that much better than the plastic clip. I like the fact that these pinch roller brackets are steel. I've seen, of course, a lot of plastic ones, and they tend to crack over time. That spring situation, the way they designed this, is a little awkward. They tried to make it easier by adhering the spring in one direction or on one end, and that's helpful, and I appreciate that. But I think they chose the wrong end here. Okay. Propping that head stack up in its play position. I don't anticipate any adjustments needed here because I haven't changed anything from the factory settings, and they should be spot on. I want to double check the pinch roller alignment also. A lot can also be deduced by the fact that the head was not unevenly worn, more one side than the other. And that's surprisingly common. I see that a lot. I have shown this in much more detail in one of the past videos where I've tried to get really close and point out what I'm looking at. So on this one, I'm just going through it and doing it without getting up close. So now it's time to take a decision on the surface treatment on the capstan shaft. And what I've done here is I have bead blasted a gauge pin from my collection to see if my media is similar or close enough to the factory bead blasting to go ahead and do the job, or if I need to order something different. And so I've got the two shafts sitting next to each other. This is my bead blasting on a gauge pin, a little bit smaller diameter, but it'll be similar material. And that's what mine looks like. This is the factory capstan job. Slightly worn, of course. You can see the wear marks there horizontally. I don't know what that vertical line is unless it's just happened from pulling the capstan out of the bearings. This is up pretty close, and micro scratches are very easy to see. But that's their job. That's their bead blasting job. And now that I'm seeing those horizontal wear marks, I'd like to take care of this and bead blast it, make it uniform again. Now this is an interesting thing. Again, the capstan shaft is on the left, and my precision ground gauge pin is on the right. And so I'm looking at the surface finish on the two. And yes, this is an old gauge pin, and obviously it's not one I use or I wouldn't have bead blasted it. But shockingly, that capstan has a much finer grind job than the gauge pin does. And I don't know the quality of this gauge pin. It was just something in my stash, but that capstan is really ground fine. And, for those that may not know, gauge pins are used for precision gauging, precision measuring of bores and holes. So that's my transition using the polyurethane tape, masking it off. And then compared to the factory Denon masking off. And so I'm comfortable with that. I'm happy with how that looks. So looking at these two closely, I'm satisfied that what I have here in the shop is sufficient and very close to equal to what they did. So I'll go ahead and do that. And there's the whole thing masked off. Obviously, I'm not going to take the camera in the bead blaster with me or even outside, but it turns out quite nice. Just try to find every contact point. And there's my surface finish job. Looks really nice. I'm very happy with it. We'll get that all squeaky clean. During the course of having this apart, I've put drops of oil in those capstan bearings every so often, front and back. The front is actually more important than the back because of the force applied by the pinch roller. The back is pretty much freewheeling. That belt makes very little force on those bearings, but the front is under much greater force from the pressure of the pinch roller. So one thing I see that I don't like is people just putting lubricant on the shaft and then running the shaft down in the bearings. That's not sufficient, and I'm going to do a video on this soon in a way that I can demonstrate how all that does is push all the oil up into the back of the capstan and gets nothing in the front bearing. And the front bearing is the most important place that it's needed. If I did nothing else to maintain my decks, I would slip that oil retainer back a little bit and apply oil to the front bearing and then slip the oil retainer back. That would do more than putting oil on the shaft and placing it in the bore. So this is the thrust side, and the thrust side gets a little bit of grease, not oil. I'm actually washing my hands with isopropyl before I touch the capstan belt or the capstans. I'm going to clean the capstans now for a final time. I want them absolutely dry and absolutely clean, and I'll also blow them off with compressed air before I assemble and put the belt on. I'm trying to get the lowest flutter numbers I can get, and having a little spot of grease or debris on a belt or a capstan pulley could possibly make that worse. So that's what I got off after everything's clean. And it's not my hands. I'm OCD about washing my hands, but anybody that works with tomatoes knows why my hands look this way. Or has a garden, or works with tools and equipment. I guess it would help if I put a motor in first. Cleaning my dental pick that I've been using to grease all the parts. And the motor board has already been recapped in a previous video. Okay, that's actually a little bit tight. It's not operating quite as freely as it should. I have a quick feel of the end play on that left capstan, and it is, I really can't feel much. So let's check that end play. Now the way this gets adjusted is that nylon thrust bearing right there with a hex driver. And with a bigger one than that. I'll try to get this set up for the camera. Now, ordinarily, I would do this operation down on the surface plate with a different indicator that has a square or a flat point on it. But I don't have a flat point for this indicator. I also don't have on the surface plate two cameras set up with lights that are adjustable and that I can get perfect angles on and show this the way I want to show it. So I'm improvising here on some flat cork plates that I use. I actually normally, when I'm not videotaping things, I do all my work on cork, the carpet is strictly for the video, not because I like working on it. I just don't like the way the cork looks on video. But in this case, I have to use it to keep things from sliding around, and it's very flat. Okay, so you can see the tip of the indicator is just contacting the tip of the capstan. And I just work on it for a minute to get it aligned. And try to get the lighting set up. Thank you for your patience. Now, obviously, it's important to try to settle everything down, and I can see that I'm not dialed in here, and the reason why is I don't have my indicator locked down. I didn't have it seated all the way in, and so when I tapped around on the bench and on everything was moving around. Okay, I think that's even a little bit better angle. You can see the tip of the capstan contacting the indicator tip. No, I've still got something rocking somewhere. Probably have a little debris underneath something. Yep, it shouldn't be like that. It should be solid. So let me figure that out, clean things up, and put it back together. All right. I'm on terra firma now. So the procedure here is to push in, and if you can, set the indicator on 0, and then pull out and take the reading. And what they're asking for is 0.2 to 0.4 millimeter. And that translates to roughly 8 to 16 thousandths on this indicator. This indicator reads in 10 thousandths, and so each of those hash marks is 1/10,000th. Okay, got a good view of the tip of the indicator and the tip of the capstan here. And there's the end play. That's what I'm measuring, is that amount of back and forth movement, lateral movement. Okay, and I was not near 8 thousandths. I was way low from that, something like maybe 3. Okay, so there's 5 on the push side. Yep, that's about 5. I'm looking for 8. We'll just settle everything back in again. Okay, that's more like 8 just on that side. And then I've got, you know, maybe 1 or 2 on the other side. Okay, let's tighten that up just a scoosh. Another view of the end play. The reason it needs this is for thermal expansion. Everything heats up and metal expands, of course, as it heats up. And if it's right on the edge, it will put undue force on the thrust bearing, and it just won't run very accurately. So it just needs this for heat. Okay, so there we have what, 7 on the push side, and maybe 7.5. Again, remember we're looking for 8 to 16. So that's quite a range. I'd like to get it on the low end, of course. All right, let's pull it back here. Pull it back if I can. It looks like I'm reading 1 on the pull side and about a 7 on the push side. And because I went to grade school during the 60s, I can actually add 1 and 7 and come up with a number that doesn't really care about my feelings. So that puts my capstan end play in spec now. Let's put it together and check it out. I'll be very happy when I have a chance to do a little wire management on this deck. Can you imagine if I hadn't marked these connectors? Actually, in Denon's manual, to their credit, they have a schematic of the connectors. Okay. We're all plugged back in. I'm really confident that this is going to work just fine. Got good torque. Let's grab a tape. I think I'm in the mood for a little werewolf serenade. Oh, come on, you're singing along. I know you are. Yeah, I had no doubt that this would operate correctly. This tape is one that I made in the, early 80s, late 70s, probably on the first deck I ever bought brand new or could afford to buy. And the funny thing is, it still sounds pretty good, you know. It still brings a smile to my face. Yeah, it's operating exactly as it should. I wouldn't have risked this tape if I had any doubts. Last thing I need to check here is the pinch roller tension. And that's very simply done by kind of moving that pinch roller off. Of course, you want to try to be on center of axis. Just moving it off of the capstan and then putting it back on until it just barely starts to rotate again. And I'm actually a little bit light on the left pinch roller. My spec on these is, the specs are right there in grams. My meter's reading in, or my gauge is reading in centinewtons. And the conversion on that is something like 0.98. It's very close, unless you're at the far, far extremes of the spec. Then it's essentially a one-to-one conversion. And I'm actually reading a little bit light on the left pinch roller. Supply side is just a little bit light, and I take care of that just by giving the spring a rotation, and then it brings it right into spec. And here's the tape travel. This is a really nice close-up, or I'm trying to get a nice close-up of it. The travel on this thing is just solid as can be. It's not touching either guide. Right in between them, it's running solidly. I don't know that it could be any better than that. Did this board off camera. I'll do some more board work coming up. I don't know how much soldering and recapping people can actually tolerate in a video. So I'll do a little bit coming up, but this one's done. It's ready to be put back in. Maybe people like it. Who knows? If you like it, comment. Let me know. All right, time to get the audio board out. This cable management reminds me of my homeless Persian cat's fur if he hasn't been brushed for a week. I'll reserve comment on Denon's cable management for now. I will give them credit for using connectors instead of those awful spiral posts that I have to, and they did use that on the transformer on here, and I did have to desolder all those to get that board out. But some of them, just use them everywhere, and it's a nightmare. Looking at this closely, I can see a dozen, maybe 2 dozen reflowed joints. Probably warranty, probably from, warranty job. I know I have this one intermittent channel on the RCA jacks, and right there, if I can get this focused, is the reason for that cracked joint. And of course I anticipated that. I wasn't worried about that at all. I was almost 100% confident that's what that would have been. And I'll remove the solder and completely reflow all of those, not just that one. But here I can see some evidence of reflowing. There's nothing wrong with that. It's, like I say, it was probably a warranty job. But you see them kind of scattered around. That's okay. I'll have a really close look at this and go through and just reflow anything I need to. Yeah, pretty obvious on that one. But overall, looks good and clean. Nice wide traces like I mentioned in the past. In my mind, I believe that wide traces equal better sound. You can think of that what you want, but that's my opinion. Yeah, see that's not a factory solder joint. There's a lot of those. All right, let's get busy. I've made a list of the capacitors I need. I do, especially on audio boards, or probably really only on audio boards. I do match capacitors left to right channel. In fact, in in a case like this, I kind of double match them. I'll get them sorted in a group, and then I'll go back and especially on this deck where there aren't a million of them to do, I'll dial this down into a finer range. Nichicon FGs here. I think I mentioned this in another video. I really like the sonics on this deck, and I don't want to do anything to change their character. I want to clean it up, quiet it down, but it sounds good when I test it originally, and I also, I also test it as I go through the boards. That way I know if I made a mistake on something where I made the mistake. And so I've listened to this deck now for a little bit of time, and I just like it. I like the way it sounds. It's just a fun deck, and I don't want to change any of that. Put some audio grade capacitors in the signal path, clean it up a little bit, and hope it sounds the same and better when I'm done. I like to clean my pads with the solder wick and kind of scrub them clean. This is all, no lead solder, and I'm going to replace it with leaded solder. And so I want all of that as clean as can possibly be. I want it all gone. I don't want any trace of the old solder on there. This is the signal path, and I want it to be 100% clean. It doesn't matter to me if it's signal path or not. My procedure is the same way. I believe that the accumulation of contaminants in solder builds up and equals poor noise. Not poor noise, more noise. I've satisfied myself that that's true. So to me, everything needs to be cleaned. I also clean the solder, or the solder, however you want to say it. The other thing I like to do is do one leg at a time in sequence, and then move on to the next component, and then come back and do the second leg. I believe, I don't know this for a fact, I believe that it decreases the total amount of heat on each component. I'd be curious if anybody has any data on that, but that's how I do it. Yeah, do a little cleanup on the potentiometers. I didn't have any issues or any scratchiness with the pots or the switches on this, so this is just kind of routine maintenance. I'll clean them out, blow them out, and on the pots I'll put fader lube. I know there's a big controversy about using deoxit D5, the red stuff on potentiometers. Prior to about a year or so ago, maybe a little bit more than that, on Deoxit's own website, they were recommending against D5. They were recommending Fader Lube. And then the whole internet controversy blew up, and they've removed that since from their site. I still think it's sound practice to clean them with a non-filming cleaner, blow them out, and then add a little Fader Lube that acts as both a dielectric and a lubricant. So that's my theory. I welcome any comments on these things. I think this controversy may have started when somebody on the internet posted that a chemical in Deoxit D5 or the red dissolves carbon in the potentiometer tracks. And that's obviously very false. No chemical in Deoxit is going to dissolve carbon. I think maybe carbon tetrachloride might be able to, but we can't get that anymore. And it certainly isn't contained in Deoxit. I think what's possible on maybe some very old pots in very old vintage equipment is some of the chemicals in Deoxit might partially break down very old binder in old carbon tracks. That's the most likely thing. But, you know, the company has to protect itself, and I understand that. I don't think it is the best. I think the Fader Lube is the better product, and so that's what I use. Now on the switches, that's another matter altogether. I'll do the same cleaning procedure on them, but I will use the red Deoxit on the switches. Again, it's acting as a dielectric and a lubricant. And I had no issues with any of these switches. There was no scratchiness. There was nothing to indicate any problem. This is just a normal maintenance. And I'm also, if you see, I'm blowing out after I'm finished. I'm blowing all the chemicals out of these switches and leaving the tiniest film I possibly can. So I'll just put just the tiniest drop I can. And then I'll blow it in with compressed air. And that leaves about the tiniest amount of film that can be left. Also want to have as good as contact as I can get on the connectors, and so I'll use deoxit D5, which is the perfect chemical for this, and just clean up these RCA jacks. Watch how isopropyl alcohol basically does nothing. You know, as soon as it evaporates, they're just as dull as they were. They're clean, but they're oxidized. Now, deoxit, as the name implies, takes the oxidation layer off of these, and it does so beautifully. Come on, camera. Now look at that. They look just like brand new. With that tiny amount of effort. I'm just going to do the same thing with the phone jack. Now the last step here is to use the what is that, S100 product? The blue deoxit, which is a contact enhancer. And I put that on all the connectors. The other good quality of it is when I do these, of course I'm plugging and unplugging the connectors generally multiple times, and this just makes everything glide so much more smoothly and reduces the risk of anything binding up and causing damage. And this is how it all turned out. And if any of you managed to stick with me through this hour and a half, I truly appreciate it. And I look forward to your comments. Thank you for watching.